Okay, so what we're looking at here is a real simple procedure that involves recursion. And what I want you to notice is, first off, the name of this procedure is called recursive procedure. I've gone ahead and put a variable x in this case that allows us to keep track of how many recursions we've gone through. You'll see as we step through. But what I want you to notice is this line right here that's called call recursive procedure. And what that does is every time this line is executed, instead of going down to the next line, it actually takes this whole procedure, puts it in a stack, and it goes to that procedure. In this case, the procedure that it's calling is the procedure we're in. So let's go ahead and step through the code so you can see what I'm talking about. So we start here. Our variable starts off as 0. We add 1 to it, and now we're going to call this procedure. In this case, the procedure that we're calling is the one that we're currently in. So watch what happens. It goes back up to the top. What it's doing is it's not really looping. It's actually calling this procedure. If we had another procedure here by a different name, it would call that procedure and it would go to that one. Instead, what's happening is because we're calling the procedure we're in, it gives the appearance of a looping. So if you notice, it keeps going, and if we watch our variable, it increases. So now we're up to 5, 6, and since we don't have a conditional statement or a means to exit these recursions, it's going to go on indefinitely or until we run out of call stack room. Because each time we call our procedure, it puts the previous instance of that procedure into a stack. So right now we're in this procedure. We're in procedure number 7. We go here, and whenever we get to this procedure, this portion of the procedure, notice how what's going to happen is that this current procedure that's being executed, it's going to be stop or pause if you want to think of it, put into the stack, and it's going to go to this new instance of the procedure. And we keep going and going infinitely or until we run out of room. So what I'm going to do is I'm going to go ahead and run this until we get an error. So here we have runtime error number 28, out of stack space, or what's commonly known as a stack overflow error. So I'll go ahead and debug it. And let's see how many instances that we had. In this case, we had right at about 6,804. So after that many recursions, we have run out of room. Okay, so now we have a very similar procedure that also involves recursion, only this time I've placed a conditional statement. So what I've done is now, whenever our value of x is greater than or equal to 3, we're going to exit out this procedure or this instance of the procedure. So let's go ahead and step through it. So we start off with a value of 0 for x. It's now up to 1. Is that greater than or equal to 3? The answer is no, so it keeps going. We call this procedure again. And now our value is up to 2. Again, it's not greater than 3, so we go through another recursion. And now our value is equal to 3. So now we've met the needs of our conditional statement. We will exit this sub. Now keep in mind that when we exit this procedure, we exit or end this instance of the procedure. So currently we are in recursion number 3. Now watch what happens. I exit. We have gone back to recursion number 2, the second recursion, and we've continued down the line. So remember we were here when we left off with recursion number 2. Now we've gone to the next line. Now we are ending recursion number 2. Again, we're ending, we were at this portion of the code and we'll drop down to the next line. All right, so now we're down to recursion number 1, which is the first instance of the recursion, so the first instance of the procedure, and this should actually finish everything. And now we're done. So what I want you to notice is that by putting in a conditional statement, we're able to exit out of our recursions and avoid any kind of stack overflow error. The other thing to keep in mind is that when we go through these recursions, which I'll go ahead and do again, go ahead and speed through that, is that remember, whenever we exit out of here, it's going to go to the very next line. In this case, the code that's executed is a simple subtraction. What you need to be mindful of is that whenever an instance of a procedure ends, that the next line is what's going to get executed in the previous instance of the procedure. Really, the best thing to do is write a simple recursive procedure yourself, like the one you see here, and play around with it and see what kind of effects it has. Try putting the conditional statement in different locations. So for instance, if I were to go ahead and take this conditional statement right here, and I were to move it down to afterwards, you'll probably notice that whenever I execute our procedure, this conditional statement is never read. So we'll end up with a stack overflow error again. All right, so this is just a simple example of a recursive procedure and how it's carried out actually through our code. The big thing to keep in mind is that a recursive procedure calls itself, and we only have a limited amount of space in our call stack. So what we need to be mindful of is that whenever we do work with recursive procedures, we want to make sure that we don't end up with like an infinite loop of recursive procedures, because that will crash our program. So hopefully you know a little bit more about recursive procedures, how to use them, how they work, the errors that are involved with them, and how to avoid them. So if you found this video useful, please click like and share with others. Thank you.